Welcome to the McDaniel College Laboratory Safety Training. Today we will be talking about safe practices within the laboratories to help ensure your safety and health. Our goal is to ensure that you go home at the end of the day the same way you arrived this morning. There are employee and student responsibilities. You must perform work in the safest manner possible. You must follow all college policies and procedures. Forms and Policies page can be found on the portal under Faculty and Staff Resources. Report any health or safety hazards to the Office of Risk Management and EHS. It is the responsibility of the faculty member to continually train their students in all lab procedures. Dress code when walking into a lab. When walking into a lab, no matter what you are doing in that lab, you must be wearing the following: long pants and closed-toed shoes. Dress code when working in a lab. When working in a lab, you must be wearing the following: long pants that extend beyond the ankle. Leggings, spandex pants, tights, and yoga pants are not acceptable substitutes for long pants. Closed-toed shoes that cover the entire foot. No flip-flops, sandals, ballet flats, Crocs, or high heels. Hair should be tied back, and exposed midriffs are not permitted. Personal protective equipment, PPE. Lab coats. Lab coats must be worn while working in the lab and must be fully buttoned. Chemistry lab coats are disposable coats made of Tyvek or Tyvek alternative and are white. Use care when working around open flames in Tyvek lab coats. Tyvek can melt when exposed to direct heat. Biology lab coats are disposable coats made of a non-woven fabric and are blue. They do not offer protection against chemical splashes. Students may also wear cloth lab coats in any lab. Personal protective equipment, PPE, lab coats. Students should print their name in marker on the back of the disposable lab coat. Students should not share lab coats. Student lab coats are to be kept in storage bags in the designated drawers or plastic storage bins within the lab. Lab coats cannot be taken back and forth between labs. Cloth lab coats must be laundered after each semester prior to the user removing their lab coat from the building. Personal protective equipment, PPE, eye protection. Safety goggles have guards on the side of the face and a shield on the top of the goggles that meet the forehead. Prescription glasses and contact lenses do not provide protection. Safety goggles must be worn in the following scenarios: handling chemicals hazardous to the eyes, using chemicals with unknown hazards, working with gases, working with liquids which are hotter than 60 degrees Celsius or 140 degrees Fahrenheit, working with solid materials, i.e. glassware, or equipment that might cause fragmentation or flying particles, when dust or fumes are present, and when working with preserved specimens during dissection activities. Personal protective equipment, PPE, hand protection. Ensure you are using the correct type of glove to protect you against the materials that you are working with. Rings should not be worn under gloves as they may puncture the glove. Remove gloves when touching any surface in common areas such as hallways, keyboards, doorknobs, elevator buttons, etc. Remove gloves when leaving the lab. Use a cart or secondary container to carry hazardous materials in the hallway. General safety rules. Students may not remove any biologicals, chemicals, or reagents from the lab without the permission of a faculty or staff member. Do not use broken equipment. Place out of service and inform a faculty member. Keep cell phones, extra books, clothing, and personal possessions away from the lab bench to prevent contamination. General safety rules. Lab doors must be closed and locked when work is not being conducted. Use the buddy system while lab work is in progress. Faculty member must be aware of the work students will be doing. Projects involving chemicals on the high hazard chemical list must be conducted with a faculty member present. After hours work, faculty member must send a list of student names and permitted room number to campus safety at the beginning of each semester. Student must call campus safety to be let into permitted room. Student must have a buddy and must show McDaniel ID for access. Lab hygiene. Eating, drinking, chewing gum, applying any lip products and/or makeup is not allowed within the labs. Do not put any pens, pencils, or gloves in your mouth during lab work. Wash your hands with soap and water whenever reagents contact the skin and before leaving the lab. Keep the lab clean. Wipe down the benchtop with a designated cleaning material after each experiment. Work involving bacteria. Lab benches must be disinfected with an EPA-registered disinfectant after each lab experiment. Return chemicals and equipment to their proper places, dispose of trash, and make sure the drains are uncluttered. Housekeeping. The laboratory should be kept clean by wiping down the counter with the designated cleaner after each lab experiment. When working with bacteria, lab benches must be disinfected with an EPA-registered disinfectant after each lab experiment. Return chemicals to their proper places, dispose of trash, and make sure the drains are uncluttered. When using gas or vacuum outlets, make sure they are turned off before leaving the laboratory. Return any personal protective equipment to its designated location. Blackboard Safety Course. Students must complete the lab safety training on Blackboard by the deadline provided. Training and quiz are the same format as last semester. Lab safety agreements are electronic. Any student registered after the deadline will need to be added. Please let us know ASAP. Typical questions. Why is the page blank when I click on the link? There is a Mark Reviewed button that they must click to proceed. Why am I still on the list that I have not completed the training? You may not have completed the lab safety agreement. Fume hoods. Face velocity should be around 100 fpm at the sash height of 18 inches. Ensure sash is not above the sash line indicated by the sticker. Work with the sash between 12 to 18 inches high, depending on the user's height. Ensure all chemicals are in secondary containers within fume hoods due to sinks. If there is a problem with the fume hood, close sash, place out of order sign on sash, and contact physical plant. Chemical inventory. This is a collective list of all chemicals in each lab and on campus. All chemicals must be barcoded. Remove the barcode from chemical container when empty and place in the waste area. Tori will remove barcodes from inventory. Chimera. This is reconciled yearly. All faculty should have their own login for Chimera. Students can obtain access on a case-by-case basis. The chemical inventory is then submitted to the local fire department. Safety data sheets, SDSs. SDSs explain all the necessary information for the chemical. Information on SDS must be presented using specific headings in a specific sequence. It must be in English, and it must be readily accessible to all employees during their work shifts. These are accessible on campus in binders in 208 and through electronic access, Chimera. Chemical labeling. All chemicals must be labeled with the contents. Full chemical name must be written out. Abbreviations and chemical symbols do not meet regulation requirements. Household grade chemicals do not need to be relabeled. Manufacturer's labeling is adequate to communicate the hazards. Primary container labeling. This is the manufacturer label. We use the Globally Harmonized System, GHS, for the classification and labeling of chemicals. Workplace container labeling. This is secondary container label. We use Globally Harmonized System, GHS, for the classification and labeling of chemicals. Proper labeling under GHS. You will use a signal word. This indicates relative level of hazard. Danger is used for most severe instances, while warning is less severe. Product name or identifier. Hazard statements. Phrases that describe the nature of hazardous products and oftentimes the degree of the hazard. Precautionary statements. Phrases associated with each hazard statement that describe general preventative, responsive, storage, and disposal precautions. Manufacturer information, including name, address, and telephone number. And then symbols, hazard pictograms. These convey health, physical, and environmental hazard information with red diamond pictograms. May use a combination of 1 to 5 symbols. The following are the GHS hazard pictograms and their related hazard classes. These pictograms include exploding bomb, corrosion, flame over circle, gas cylinder, environment, skull and crossbones, exclamation point, health hazard, and flame. A DOT label is separate. A bottle will come with a GHS label on the container, and then the box will be DOT labeled. NFPA 704 diamond. Fill in chemical name, no abbreviations, owner, and date. The diamond fully filled out using Chimera. If using a diamond for 2 or more chemicals, look up the chemicals and take the highest number for each color. There are 4 sections: health hazard, fire hazard, reactivity, and specific hazard. Chemical storage guidelines. All stored chemicals must be labeled. This minimizes the hazards associated with accidentally mixing incompatible chemicals. Never sort and store chemicals alphabetically. Store all chemicals by their chemical family: acids, bases, flammables, etc. Ensure caps and lids on all chemical containers are tightly closed. Never store chemicals under sinks. Never store chemicals above 5 feet, and never keep expired chemicals. Any question on chemical storage, just ask. Cylinder storage. Always secure cylinders with straps or chains connected to a wall bracket or fixed surface, or place cylinder in a rack or stand. Always keep cylinders upright. Separate by compatibility. Store in a cool, dry, well-ventilated area. Ensure usage tag indicates correctly. When cylinder is empty or not being used, ensure that the valve is closed. Waste management. There are different types of waste streams: hazardous waste, biohazardous waste, universal waste, non-hazardous waste, radioactive waste. Each waste stream is disposed of in a different manner. Hazardous waste, radioactive waste, biohazardous waste, and universal waste are carefully tracked. Be conscious of all types of waste. If you are unsure of how to properly dispose of your waste, contact the Office of Risk Management and EHS. Hazardous waste. Hazardous waste is regulated by the EPA and the MDE in Maryland. Waste is considered hazardous when it shows characteristics of ignitability, corrosivity, reactivity, toxicity. There are listed hazardous wastes. The F list is non-specific source waste, e.g. spent solvents. The K list, source-specific waste, e.g. ink sludges containing chromium or lead. Then there's the P list and the U list, discarded commercial chemical products, e.g. sodium azide and acetone. Hazardous waste. Satellite accumulation areas, SAA, can be found in many of the labs. Hazardous waste is held here until it is transferred to the Central Accumulation Area, CAA. A contracted vendor picks up all waste from the Central Accumulation Area. Central Accumulation Area and Satellite Accumulation Areas are highly regulated by the MDE. Hazardous waste, Title 40 CFR. Resource Conservation and Recovery Act, RCRA, requires the EPA to publicize and enforce regulations regarding the management of hazardous waste. Mandatory procedures for compliance must be followed by facilities where haz waste is accumulated, transported, treated, or disposed, cradle to grave. We are considered a large quantity generator under MDE. Waste must be removed from campus within 180 days of the accumulation start date. There's a new setup for waste containers and labels located in Eaton 103, 301, and 208, small, medium, and large containers. Ready for disposal labels. Labels can be picked up in 301 and 208. Chemical waste. Waste from lab courses. Discard into the pre-labeled containers placed out by the chemistry lab manager, biology lab manager, or instructor. Waste from research labs. Place a hazardous waste label on the container. Fill out the label completely with chemical contents, no abbreviations, amount, and accumulation start date. Place into the secondary container in the satellite accumulation area. Chemically contaminated sharps. Place into the white puncture-resistant sharps container. Fill out the label with what the sharp is contaminated with. Biological waste. Animal carcasses and tissue are collected into the labeled bins. Sharps, needles, syringes, blood tubes, etc., must be placed in the red puncture-resistant sharps containers. Autoclave items are collected in the labeled bins with clear bags. Biohazard waste that cannot be autoclaved is collected in the biohazard boxes with the red bags. Empty containers. Empty manufacturer containers. Leave empty manufacturer chemical containers in the satellite accumulation areas. Ensure that the barcode on the chemical is not removed from the container. Empty secondary containers. Remove or deface the label with permanent marker. Rinse the container out. Rinse into a waste container or place full container into SAA if a P-listed chemical. Other types of waste. Universal waste, bulbs and batteries. Contact the Office of Risk Management and EHS for disposal. Non-hazardous waste. All non-hazardous waste can be placed in the trash unless otherwise specified. Gloves and paper towels, unless heavily saturated with chemical or biological material, can be placed in the regular trash. Non-contaminated broken glass should be placed into broken glass boxes, labeled cardboard boxes, which can be found throughout the laboratories. When working with hazardous substances, it is important to understand the potential hazards associated. Hazard determination is the process of evaluating available scientific evidence in order to determine if a chemical is hazardous and provides the basis for the hazard information that is available on the safety data sheets, labels, and in employee training. We rely on the manufacturer's hazard determination when we purchase chemicals. That is why it is so important to read the safety data sheet and label that the manufacturer provides prior to using any chemical. Physical hazards include fire, which are flammables and oxidizers, explosion, compressed gas and explosives, and reactive, organic peroxides, water reactives. There are also health hazards, including systemic effects like carcinogens, toxins, irritants, and target organ effects, including reproductive toxins and neurotoxins. Now let's talk about the hazards you may find in the lab. Hazardous materials can enter the body in 4 different routes. Materials can enter through inhalation, which is through breathing and is the fastest way into your system. It is important that you understand what chemicals are being used when entering a lab, as some chemicals are odorless and can overcome you very quickly. Absorption occurs when a chemical is absorbed through the skin or eyes. This is why it is important to wear the proper personal protective equipment. Ingestion occurs when swallowing the material. Many people do not think about washing their hands after leaving the laboratory. But what if you had a microscopic hole in your gloves and you did not wash your hands before lunch or before heading home to your loved ones? It is important to think about these scenarios to ensure that you keep yourself and others safe. Injection, which penetrates through the skin, can occur if a contaminated sharp is thrown into the trash and a custodial worker goes to empty the trash. Ensure proper storage and disposal of all materials within your lab. There are 2 types of exposures, acute and chronic. Acute exposure is short-term exposure and symptoms tend to be seen quickly. An example would be a chemical burn to the eye or skin, as seen in the pictures on this slide. Chronic exposure is gradual exposure over time. Symptoms tend to be seen years down the road. An example would be asbestos exposure. Most people do not see the effects of asbestos exposure until 10, 20, or even 30 years after the exposures occur. That is why it is important to understand what you are working with today, because it could have grave effects on your health years down the road. To reduce the chance of exposure, we need to identify the hazards, receive training, use engineering controls, workplace behavior controls, and personal protective equipment. Because people are exposed to chemicals through their work, the Occupational Safety and Health Administration, or OSHA, has set limits for the maximum levels of exposure an individual can be exposed and not suffer adverse health effects, called Permissible Exposure Limits, or PEL. Exposure limits are published and enforced by OSHA as a legal standard. OSHA PELs are based on an 8-hour time weighted average exposure and can be found in tables Z1, Z2, or Z3 of 29 CFR 1910.1000 on the safety data sheet or via www.osha.gov. In some instances, there may be indicators of exposure to hazardous chemicals. If there is an odor, you can taste the chemical, particles are in your respiratory system, you have acute symptoms, you see visible material in the air, or there is settled dust when there should not be, these may be indicators that you have been exposed. Seek medical treatment immediately if you have been exposed. On this slide, you can see the hierarchy of exposure control methods. First is elimination. If you can eliminate the chemical altogether, there are no hazards. However, that is not very practical when working in a laboratory. The next method is substitution. This consists of using different, less dangerous chemicals instead of highly dangerous ones. While these first two methods are the most difficult methods to implement, they are the most effective. Engineering controls remove a hazard or place a barrier between the worker and the hazard. Examples include chemical fume hoods and biosafety cabinets. Using safe work practices and administrative controls helps the worker ensure that they are following guidelines created for them to keep them safe while completing their work. Standard operating procedures and proper housekeeping are examples. Personal protective equipment should be your last method to control exposure. If you cannot work safely with all of the other methods in place, you must use personal protective equipment. Examples of PPE include gloves, safety goggles, and respiratory protection. Lab hazard information signs. These signs must be posted outside each lab. They are updated yearly. They provide critical information including 24-hour emergency contact information, lab hazards information, including the NFPA diamond and GHS pictograms. Always read the lab hazard sign before entering the lab. In the event of an emergency in the labs, contact Campus Safety and the Office of Risk Management and EHS. For Campus Safety, dial 2202 from any in-house phone, or dial 410-857-2202 from any phone. For the Office of Risk Management and EHS, there's Ethan Harden, whose office is in the physical plant. His number is 410-871-3123. Tori Isley's office is in Eaton 304. Her number is 410-857-2489. Sean Wellman's office is Eaton 218, and his number is 410-857-2480. Contact information can be found on the lab hazard information signs posted outside of every lab. Medical emergencies. For incidents involving first aid and/or other emergency equipment, i.e. shower, eye washes, etc., contact Campus Safety and the Office of Risk Management and EHS and fill out the laboratory incident report and send to the Office of Risk Management and EHS. Exposures. If you are exposed to a hazardous substance, inform someone immediately to determine the next step using the SDS or label. Flush the area with water for at least 15 minutes unless the SDS or label says otherwise. Contact Campus Safety and the Office of Risk Management and EHS. Always seek medical attention following an exposure. Once safe, report the incident to your supervisor. A laboratory incident report will need to be completed. Spill response. Students. If you can do so safely, block off any drains so the chemical does not make contact. Remove others from the affected area. Close the door to the room to contain the spill. Report the incident, including the chemical name, to a faculty member who will clean up the spill or call for assistance. Spill response. Faculty, staff. Do not clean up a spill if you do not feel comfortable. Chemical spill under 4 liters. Remove others from the affected area. Ensure you have a buddy to assist you. Spill kits are located in or near every lab. Use the correct PPE to ensure you are protected from the chemical or biological. Choose the correct material to clean up the chemical or biological that was spilled. Spill response. Faculty, staff. Chemical spill under 4 liters, continued. Ensure to block off any drains so the chemical does not make contact. Use tools to pick up any broken glass. Work from the outside in as shown below. All cleanup materials must be disposed of properly. Put into a bag, container, label, and place in the closest satellite accumulation area. Send a laboratory incident report to the Office of Risk Management and EHS. Spill response. If the spill is over 4 liters or a highly hazardous chemical, evacuate the area immediately. Remove and notify those in danger. Close the door behind you. Contact Campus Safety and the Office of Risk Management and EHS. Training requirements. Training is required for employees who work within a laboratory at the time of initial assignment, yearly, and whenever a new hazard is introduced into their work area. You have reached the conclusion of the training. Thank you for participating. We hope you enjoyed the training. Please direct any questions or comments to Ethan Harden. Thank you.